The video for this is for this worksheet, the thermodynamics practice, conduction, convection, radiation. All right, looks like that on the front, looks like that on the back. All right, so the first section here reads matching, identify the definition for each. So you read through this, you read through this, and you read through this, and identify which of these is conduction, which is describing convection, and which is describing radiation. Okay? Go ahead and pause the video and do that this time. Okay, so to answer that one, heat transferring through a solid object and heat transferring through touching objects, that is describing conduction. Infrared heat waves, heat traveling through a vacuum, traveling in all directions from the heat source, is describing radiation. Hot particles rising, cold particles sinking only in fluids like liquids and gases, and particles moving in the currents, that's describing convection. Question number 1 right there. Feeling the heat from the sun. You are going to consider, okay, is that describing conduction, convection, or radiation? Heat we feel from the sun, and then you're going to give an explanation why you gave it that answer. So somehow either go back to those definitions of conduction, convection, or radiation and explain why it is using those definitions. Or you can justify that it's not the others. However you want to do your explanation, whichever makes more sense to you. So, doing the first one together. Heat we feel from the sun. Well, that is radiation. Infrared radiation can travel through the vacuum of space. So from the sun to the earth is empty space. Only radiation can travel through a vacuum. Going back to that definition, can travel through a vacuum, therefore it's radiation. So that's doing number 1 with you. I want you to go through numbers 2 through 14. Okay? You're going to pause this video for a really long time and you're going to go through those questions. Do it with a partner. Go through, look at the definitions, consider the question, go through and figure out each one of those and give me some sort of an explanation. Substitute, go through once you see that the students have them all hold up their paper front side and then have them all flip it over back side. Once you see that they have completed those questions as a class, then you're going to continue with the video. So pause to do all of those questions 2 through 14. Okay, going through the answers. Number 2. The heat we feel from touching a hot stove. All right, so if I touch a hot stove, we are dealing with conduction because the heat is transferred by direct contact. Okay, I'm going to go through these quickly. So have someone here, if they need to pause the video. So if you got the answer wrong, everyone has a chance to write down the correct explanation why. Okay, so if yours are wrong, correct them. Number 3, heat on your hands when your hands are above the fire. So the heat you feel on your hands when your hands are above the fire. Convection is the answer because the air that is the hot air, that air that is heated by the fire rises. So rising air, rising hot air is convection. Number 4, the spoon is hot after leaving it in a pot that was on the stove. All right, so we have a pot, we have leaving on the stove there, the spoon or a metal spoon in your hot cocoa or something like that, that leaving there for a long time. Why does the spoon get hot? Because of conduction. The heat from the liquid is transferring to the spoon through direct contact with the spoon, and then the heat is traveling up the spoon, passing from molecule to molecule. So that's conduction. All right, number 5, macaroni rises and falls in a pot on the stove. Okay, that's because of convection. The hot water rises and the cooled water sinks. So as the water gets really, really hot, the water at the heat source, which is down here at the bottom, this is the heat source, this is where it gets the hottest. Those molecules are hot, they rise. They get to the surface where they cool and then they sink. And as that water circulates, the pasta in the pot will circulate with it. The heat feels the snake feels from the heat lamp. So in a scenario right here in the habitat for a snake, here you got your snake at the bottom and the heat lamp's always up top. But yet the snake can still feel the heat from the lamp. Why? Because of radiation. The heat is moving in all directions away from the lamp, so it can move down towards the snake and warm it without having to touch it. Okay? Heat transfer by actual movement of warmed matter, gas or liquid. This, we're talking about convection. The fluid, the gas or liquid, is hot. So it heats up down here. It moves up, cools down, and sinks. The actual molecules are what's moving the heat. Okay? Why are vents on the floor in colder climates like Alaska? So they put the vents on the floor. Why? Because of convection. The heated air starts at the ground and then it rises. And that heated air goes up and it starts to cool down. And as it cools down, it sinks. And then it goes back to the heat source and heats up and rises. And it cools down and sinks. And you get this circulating motion in the room. All right, so this isn't on your worksheet. The vents are on the floor in Alaska, but we don't live in Alaska. We live in Laredo. And the vents in Laredo are on the ceiling. Why? Think about that for a moment. Pause. Consider that. And then turn the video back on to this for the discussion. So why are the vents on the ceiling in Laredo? Again, because of convection. Our vents are used more for air conditioning because we live in a hot climate. So we want that cold air coming up from the air conditioning to sink down towards the floor. And so therefore it cools all of the air as it comes down. If the vents were on the floor, the cold air would stay on the floor and your feet would be cold and your head would be really, really hot. All right, why is Mercury right here really, really hot and Neptune over here is really, really cold? Because of radiation. Mercury is very close to the heat source, which is the sun. Therefore, it gets more radiant heat. Neptune is very, very far away from the sun, and therefore it gets very little heat from the sun, and therefore it's colder. Number 10, insulation in homes. This prevents a type of heat transfer. Which type of heat transfer is it preventing? It's preventing conduction. Conduction, the temperature of the outside of the walls. Hot in the summer, cold in the winter. So picture touching the outside of your house on a hot day. It's hot. In the winter, you touch the outside of your house. It's cold. We don't want that heat, or we don't want that transfer through the wall. We want the temperature outside to stay outside and the temperature inside to stay inside. Okay? So the temperature outside does not affect the temperature inside the wall. So heat in the summer stays out. Heat in the winter stays in. All right, the type of heat transfer that warms a greenhouse. So this is a greenhouse. It's a building or where it's all glass, or at least one side is glass. And if you notice inside here, there's plants. So what type of heat transfer warms the greenhouse? That's radiation, because the infrared energy from the sun goes through the translucent glass, heats the ground, the plants, the pots, everything. And then as those things heat up, they heat up the air around them, but the hot air gets trapped inside. So that's how a greenhouse works. It's heated by radiant energy. Okay, number 12. Why the dog lays down next to a wood stove. So dog laying on the ground next to the heat source, the fire. Why do they do that? Because of radiation. The infrared energy moves in all directions away from the fire. So he can be laying next to it, he can be laying below it, he still gets that heat from it because of the radiant energy. It's not hot air warming him because the hot air is going up the chimney. It's not conduction, he's not touching it. It's the radiation he's getting. Okay, why do cats sit on a shelf above stoves? So what is that conduction, convection, radiation? It's convection, because the air that's heated by the stove warms up and it goes upward. That hot air rises. But we have here a couple different examples in this picture. We have here the man being warmed by radiation. Because it travels in all directions, he can sit next to the stove and feel that heat. And then we have here the teapot, the kettle, on the stove. And the kettle is being warmed by conduction because it's touching the stove. Now these you don't have to add to your worksheet as just extra examples there. So this picture actually gives us all three. Convection from the cat, the hot air rising to reach the cat. Radiation, the man sitting next to it gets warmed. And conduction, the kettle gets hot because it's touching the stove. Number 14, why you use a pot holder to get a pan out of the oven? Okay, well, that's a good question. What conduction, convection, radiation, what's going on here? What are we dealing with? Well, it's conduction, because the pot holder is an insulator. It does not conduct the heat well, which means it slows the heat getting to your hands. Your hands don't get burned. So conduction is the issue involved, is the type of heat transfer we are preventing in this scenario. So that was question number 14, the last one. All right, then below that we have these other thermodynamic concepts. So you're going to do some matching. We have here and we've got here. Which one's describing insulator, which one's describing conductor? Okay, now we are going to look at this section right here. We're doing our matching. So insulators and conductors, let's figure out the definition and identify some examples. So which one is which? Okay, so a substance that allows heat energy to easily move from molecule to molecule. Examples include metal, concrete, and ceramic. Or substances that resist the movement of heat energy from molecule to molecule. Examples include air, styrofoam, fluffy fabric, and plastics. Which one's which? So go ahead and pause and answer that. All right, so figure it out. We have conductors are the ones that allow heat to transfer easily. Insulators resist the movement of heat transfer. Okay, so let's talk about those a little more. Let's look at some examples. Insulators and conductors. Okay, so we have here styrofoam cups. Insulators prevent transfer of thermal energy by conduction. So they're preventing conduction. That's what insulators do. Styrofoam cups. Are they used for hot drinks or are they used for cold drinks? So, pause, discuss if you want to. Are styrofoam cups used for hot drinks or for cold drinks? So, hot drinks or cold drinks? Styrofoam cups are used for both. The cold drink, the styrofoam cup, keeps the heat from the outside getting in and warming up the drink. So it keeps the cold in, it keeps the heat out. For a hot drink, it keeps the heat in. So the drink stays hot longer and it doesn't heat up your hand. If you touch this, it won't burn your hand, even if the drink inside is really, really hot. Okay, another example. If you put a coat on Frosty the Snowman, does it help him last longer? Does he survive? All right, so it's a sunny day outside and you've made Frosty, so do you put a coat on him or do you not? Pause and think about that. So, what do you think? Well, the coat on Frosty actually helps keep the cold in and prevents the heat from getting into him. So it keeps the heat out and the cold in, so if you put a coat on Frosty, he'll last longer. This guy's going to melt first, this guy's going to melt last. Let's talk about conductors for a moment. Okay, so we have definition of conductors. They allow easy transfer of thermal energy by conduction. All right, so conduction happens easily through the material. So let's give an example here. What is the difference between leaving a metal spoon or a plastic spoon in your hot tea? So picture having your hot tea, you put a metal spoon in, and you put a plastic spoon in. What's going to be the difference there? Pause and think about that. So, what do you conclude? The difference is the plastic spoon is an insulator. It might get a little bit warm, but the heat doesn't transfer easily through that plastic up the length of the spoon. But a metal spoon, if you leave it in there long enough, it gets hot and that heat quickly and easily transfers up to the end of the spoon. So this spoon's going to get hot, and this spoon might warm up a little bit, but not much. All right, this is for that last section on your worksheet. Matching. So you're going to identify the definition for each. So reflect, absorb, and translucent. So look at these, access your prior knowledge, consider the examples in the explanation, and identify which one is describing reflect, which one's describing absorb, and which one's describing translucent. Pause to do that. Okay, so reflect, absorb, or translucent. So if the radiant energy goes through something, we call that translucent. Examples include glass and clear plastic. Translucent, lucent means loose, means light. So translucent, transfer, light transfers through it easily. Radiant energy goes through it. Okay? How about the radiant energy bounces off? Well, that's reflect. So aluminum foil, shiny surfaces, chrome on like the bumper of your car, mirror, they all reflect radiant energy. So that it hits the surface and it just bounces off. These are very, very slow to heat up. So if I put a piece of foil outside, it's very slow to heat up in the sun. Same with glass, because the energy is just transferring, is just passing right through. It goes right through, and this one it just bounces off. But absorption is when the radiant energy gets stopped. So the ground absorbs the energy of the sun. The earth. Black things that are dark colored, they absorb that radiant energy better. Okay? So one last concept I want to clarify. What happens to the sun's radiation when it comes to Earth? So the incoming solar radiation, 100% of that energy that gets through our atmosphere, 19% of it is absorbed by the atmosphere and clouds. So that solar heat, that radiant heat energy from the sun, 19% gets absorbed by the clouds. 51% gets absorbed by the surface. 4% of it gets reflected off the surface. So if you think about 51% is absorbed, only 4% actually bounces off the surface. That's not a lot. Remember, this is radiant energy we're talking about. 20% gets reflected off the clouds. So it got through it gets down, hits the sun, the sky, the clouds, and bounces off. So on a cloudy day, it's cooler because less of that radiant energy gets in. 20% gets bounced off the clouds, even more if it's a cloudy day. Reflected by the atmosphere. So actually hits the radiant energy that actually hits the atmosphere, only 6% actually gets reflected away. So a lot of the radiant thermal energy that comes from the sun actually gets absorbed. 51% gets absorbed by the surface of the earth. Okay, so that kind of gives you a little bit of perspective there. So that is thermodynamics, the review on this worksheet. I pretty much taught you everything you need to know about thermodynamics using this worksheet in PowerPoint. Hopefully you understood it.